Well, hello everyone. I'd like to be here with you in Auckland, but I'm in my office in Brisbane on a cold, rainy day, which is not terribly inviting. But thank you all the same. It's lovely that the organisers, the Auckland Down Syndrome Association, have asked me to prepare this presentation. What I want to talk about is the importance of allowing learners with Down syndrome to access mathematics. You'll be hearing a lot about my daughter Ruth. She's now 21 and she's taught me a lot about Down syndrome, and I've also learned from her teachers and other parents and lots of people around the world over those 21 years. And I think that's how we improve the lives of people with Down syndrome, by trying things, having a go, seeing what works, and sharing ideas. So this is Ruth, not long after she was born. Well, here she is a bit later. She completed year 12 and got the Queensland Certificate of Education. To do that, she had to get a pass in senior maths. We have different levels in Queensland, like most countries around the world. She did an adjusted senior mathematics, and I want to talk a little bit about that. But it's very important for me to be very clear. Ruth is not particularly outstanding compared to other people with Down syndrome. I wasn't able to teach her much. I can't teach my children many things at all, but there are a few things that have helped along the way. And Ruth is no more remarkable than any of the children that you're working with. And that what we know from research now is that a great deal is possible, and a great deal is possible for all that we've not really thought of before. And these are some of the things that I want to talk about in the presentation. So in my outline, I'd like to talk about the importance of learning mathematics for everyone, that it's a really important thing to think about mathematics as more than number. It's more than arithmetic. This is especially important because we know that being able to use mathematics in your daily life as an adult leads and contributes to your quality of life. But we need to think about the importance of mathematics is more than just being able to calculate. That is not enough. And not only that, learners with Down syndrome find number difficult, but with the use of a calculator they can do important mathematics. But also numeracy requirements have changed. And when I talk about numeracy, it is different to mathematics. Numeracy is the use of mathematics in the context of our adult life. So then how do we get there? What might we do? And overcoming avoidant learning styles is one of those problems that beset people with Down syndrome. They have to really work against perhaps a characteristic of Down syndrome, but we know how we can help with that. So what might be possible? If you listen to most research, it will be quite clear that not much is possible. The research is really miserable in many ways, but I think they're perhaps asking the wrong questions or drawing the wrong conclusions, because most researchers make the mistake of extrapolating difficulties with low-level calculation to say that our learners won't be able to do any mathematics. Now, it was once viewed that mathematics was hierarchical, that if you couldn't add, there's no way you'd even bother doing multiplication. If you couldn't do multiplication, well, forget about whatever. So it went along the idea that you had to go back and fix up problems before you could allow students to learn other areas. We now know that that is not the case, and that we can accomplish a great deal. So what do I mean by mathematics? I'm certainly thinking much more beyond counting, calculating, money and measurement, and they're the sorts of things that are typically in most curriculum materials. Fortunately, there is another way. Let me tell you a story about Ruth when she was just beginning high school. So she was in her year 8, and this was early on. Her maths teacher came to me and said, "I need help." I asked her what 5 plus 5 was, and she said 25. Well, I actually thought that wasn't too bad, but clearly that's not a good thing, is it? If the rest of the kids in the class are doing year 8 mathematics and you've got a student who can't reliably do single-digit addition. Well, we talked about this as a problem and tried to think about what might be possible. We at that time didn't know why Ruth, despite excellent teaching in a primary school, wasn't able to tell me what 5 plus 5 was. But I suggested that she might do something that I'd seen from Italy, where children were just given the material with support, of course, and that they were doing with their year level peers. And the teacher said, "Well, we're about to do percentages." So 3 weeks later, this is what happened. And so we see here a picture taken of the exercises that she completed that evening. She used her calculator to work out the calculation, which she cannot do. But what she can do is follow the procedure as the rest of the class were doing. So that's the work that they were learning how to do. So this is an example from another student in year 8 again. And the important thing here is that this is something that is possible for lots of students with Down syndrome. So Julian was also unable to reliably add single digits, but here he is doing some algebra. So this is what he had to do. And in this step here, you can see that the first step he's lined up, circled these p's, knows to add them together. So here we have his answer there, 7p. He's added in 24 and 3, and that's where he's got his 27 from. And now he puts it all together and he's got that lovely red tick. This is an example of what's known as year level appropriate curriculum. So this is where we teach the students material from the year level they're doing, and along the way they may just be able to fill up some of the ideas and concepts that were covered in earlier years. Here's an example of age-appropriate curriculum or year level curriculum. So this is a worksheet that was given to a boy in year 10, and as you can see, and as he certainly could see, it looks a lot like what you might give a student in year 1, and he wasn't at all happy about it. And his mum wasn't sure whether it was the right thing to do, and I suggested to the mum and the teacher who we were working with, maybe she could look at what she was doing with the rest of the class. So here was the next worksheet that came home. It's now looking much more like the worksheet that the other kids in the class are doing. Introduction to linear equations. So solve for y, he's got to here solve y equals x plus 7. The teacher's done an example, substituting in and putting the answer here. Now, the mum then wrote back to me by email as she was so excited, and she had told me that he really picked it up very, very quickly. And I said, "Have you got a photo?" So quick as a flash, back by text came this one. Now you can't see it in detail, but he has finished the rest of that table, and you'll notice that he used his calculator to calculate the different values. So he could have perhaps used other methods, but that was an appropriate method to use in his classroom. So I argue that year level appropriate curriculum is the right thing to do for our learners with Down syndrome. because it stops them getting further and further behind. If we go back and teach old material that they may not get, they may still not get it, and then they get further and further behind. It's the right thing to do, but it's also some of the best teaching you will do. The work with teachers that I've done, they get so excited when they see the progress that's made. So where are we up to so far? We've thought about what might be possible, and certainly we can teach students with Down syndrome more than number and arithmetic at that. We're going to now think about why we should do that. I ask the question of myself sometimes, why bother? Really, particularly my daughter's work, sometimes it's really tough to think about what should we be doing. And if we prepare students for a good adulthood, we really do need to be questioning these things, because the more academic work we do during their school years, the more chance in adulthood they have to continue to use that learning. Many adults with Down syndrome figuratively sit on a beach all day. Initially appealing, and appealing certainly when you're very busy, but after a time it becomes very boring very quickly, and we want to avoid that. So I believe it improves quality of life, and quality of life is a major framework in the field of intellectual disability and disability in general. I really like it because it says that a person doesn't have to change to fit in. I'm arguing as well that education matters and mathematics matters. We know that the more maths you do, the more context you can be numerated in. Remember that distinction between numeracy and mathematics. Numeracy is the use of mathematics in the context of your life. So the more you know, the more you're able to use. I think it's also important though, because times have changed. Now, I'm old enough to remember cash registers like that one. And I also remember when banking was done with passbooks. I think even my father has cancelled his passbook account, and he'd probably be one of the last people in Australia still to have one. What do we see now? Those EFTPOS machines and ATM banking have really removed the need for us to do calculation around finance in the way we once did. And they continue to change. So having ideas about money means that we have to really think about what is important in a modern world. The old things that we needed to do of counting coins and calculating change probably are becoming certainly less important, and maybe not important at all. More critical are things like how to budget, how to make decisions about money, who's giving you good advice, because we all need advice about different things. And when we think about some things like budgeting, we can have ideas that don't involve the actual numbers, but the concept instead. So we might think that your money's like a budget, your pay goes in and out goes the money with the bills. We can use that to say things like, you haven't got enough money in your bucket. And that again brings in the whole ideas of what might be important. So modern world's ideas bring in whole new ways of thinking about what's important in teaching mathematics and how do we become numerate. But I think we should never forget that there's sheer joy in doing mathematics. Well, at least certain mathematics, and depends on the way it's taught. But we should not deprive anybody, let alone our students with Down syndrome, from that opportunity to learn mathematics. So we're going to think about age-appropriate curriculum and how that might be done, and I'll talk about these things as we go. So where are we up to so far? We thought about what might be possible, and certainly more than number. Why should we do this? I think because the world's changing. What students need in adulthood are very different from what they've been in the past. and this matters for people's quality of life. So now let's have a look and think about how we might get there. Over the years, I've been involved in quite a few different research projects, but they come under three main themes. So I've looked at early maths development, I've thought about inclusive mathematics education, mainly in primary schools, but we're moving to look at secondary schools in a new project that I'm working on. A lot of this is written up in a book, Educating Learners with Down Syndrome. There's a section on mathematics, but there are other sections by other researchers looking at other areas of education for learners with Down syndrome. So that might be something that would be helpful for you. I'll just touch on a few points in this presentation. When we were working with young children and looking at their mathematics learning, we found some very interesting initial responses, and the most significant, I think, is that counting appeared to be learnt differently. So let's have a think about number, fascinating area of understanding the human brain. Well, you're a maths genius because research has shown that babies, even before 6 months old, understand quantity. So they can understand the difference between 2 and 3, they can do some simple additions, some simple subtractions, they can tell the difference between 2 and a large number, say 20. They get really stuck when it comes to something like the difference between 19 and 20. It's pretty good, isn't it? But don't be too cocky, because horses can do it, and not only that, pigeons, dogs, elephants and rats. So quite a few animals share this with us. What do we know about the concept of number? There are ideas around, there are three main aspects. So there's the quantity, there's the word and the symbol. So the quantity is a sense of how many is 3. The word can either be written word or the spoken word. So when I give it the label 3, has an image that we tag to it of what that quantity is. We can also write it as a symbol. There are lots of different symbols. If you use Roman numerals, you use a different symbol to the Hindu-Arabic system. We have to learn those. It would seem that we are born with quantity, and then when we develop words, we tag what we've known about quantity and move it over to our language system. Then when we are introduced to symbols, we tag the symbol to that, and those three things become integrated. There's still some discussion around this with education psychologists and neuroscientists working out just how we do this in our brains, but that seems to be an agreed position. What we have found in our work, and this is supported by the work of education psychologists as well in some of the published papers, we seem to see that learners with Down syndrome learn the symbol first. So they begin with quantity like all other humans and other animals, but unlike other animals, humans develop this language system. Now, it would seem that our learners with Down syndrome need the symbol first, and once they have the symbol, then they make sense of it with the word. And we've learned this, I think, in reading as well, that we know that our learners with Down syndrome can learn to read very early and learn with sight words. I think that this is very similar. But what we've learned from this is that this introducing the symbol early is important. So the implications for this, I think, are that we should focus on the symbol. That, not to say we don't say the word, certainly we would, but what we want to do is make sure we introduce the symbol very early on. Now, number lines are a great way to do this. You can have the number line all the time, right from the beginning, and have zeros on there. If you come from the country, as a lot of parts of New Zealand are, you'd know negative numbers very early. I come from the north of Australia, so we don't see negative temperatures, but when I was in Canberra, little children really little children knew negatives, that was for sure. But if everybody can see it on a number line, they will be able to make sense of it. Now, here's an example of how you can use a number line for calculating. If we want to do something simple like 3 plus 2, if we begin with 3 and let's say, well, we're going to start at 3, so let's find it on the number line, and we're now going to take away 2. So if I want to take away, I know that I've got to hop to the left. So I'm going to hop once and I'm going to hop twice, and where I end up is where I stop. Now, I've seen an example where these have Velcro dots on them, and you put the start with the green tab that you stick on the Velcro dot, and then you move it. You hop it 2 places, and then you put a red where you stopped. I must say that's a great way to do it. I also like students, once they've had the chance to practice that often, get used to doing it just with their pen. The hops stay there so they can see that it's counting hops and it's not just counting along the top, because if you count along the top, you'll end up with the wrong answer. So our result then is 1. And this can stay there for students right up into year 8, where they're learning about adding and subtracting, multiplying and dividing with negative numbers. So they're constantly having this reinforced for them. The other things are hundreds charts. We're used to seeing these printed on paper, but here's a school I was working at in Kimberley in Western Australia, and they'd painted them for the children to play on, and they had such fun with that. The other example is Feely digits, where you make the digits out of materials, and I hate crafts so much that I made them once and I decided that I'd take a photo and never do them again. There's the photo as evidence. But that idea of introducing children to the symbol very early on, early childhood maths teachers have lots of resources and ideas that can help you. What do we know about the problem with numbers? One thing we do know from research and experience, that it is widespread. It doesn't matter which country you learn, it doesn't matter which decade, who's your teacher, what program you've done. This is a very challenging area for children and adults with Down syndrome. What I think it is genuine dyscalculia, and I've written a hypothesis paper about this and worked now with a colleague who's an ed psych person, Monica Cuskelly, and we're looking at research data from over some years, and we see evidence for it. What is it? It's a very specific deficit in number processing, and here's a photo of the brain. This is the front of the head, here's the back of the head, and so the IPS stands for intraparietal sulcus, 2 parts of the brain where people who are neurobiologists believe that's where calculation is being done. There's not agreement in the research community about that yet, but it would seem there's growing evidence. We have absolutely no direct evidence through MRI about what people with Down syndrome do with calculation, because those studies haven't been done. However, there's a lot of evidence that would suggest that this is the case. This is where calculation is done, but other areas of mathematics use different parts of the brain, and other areas of mathematics are accessible to our learners with Down syndrome. So the good news is that mathematics is more than number, and that we can actually teach a great deal. So let's think about what we would need to do. If we have this issue of dyscalculia, we need to teach children from a very young age how to use a calculator. It's a prosthesis. It's a device that does what the body doesn't do easily or naturally. What we need to do, though, is to make sure that we teach students how to use a calculator. It's not something that you learn straight off. And I think it's a really important thing that we would not stop a student who needed glasses from wearing them. If we stop students with Down syndrome from using a calculator, we are harming them and we are not allowing them to learn mathematics as they need to. Some students find a standard calculator difficult. One of the teachers in the inclusive maths, primary maths study found that her student didn't respond well to the little calculator, and so she went looking for an iPad app, and she found the talking calculator to be a very effective one, and that might help some of your students. So how do we help students with Down syndrome learn mathematics? So I'm going to suggest a few tips that have worked for me, and it's important to know that there's no magic here, that there aren't special techniques that work for learners with Down syndrome all the time, and there's certainly no idea that they will only work for them and not for other kids. Things that have worked for other students will be probably just as effective, and some will work some days and not the other days. It's just a matter of trying and seeing what works. Here are a few ideas that I find helpful. I think it's important to fold mathematics into daily life so that, it's sort of not becoming a burden. Oh gosh, now we've got to find another half hour to sit down and do maths that everybody finds awful. Instead, just simple things like counting plates while setting the table, counting stairs, reading numbers wherever they are, looking at shapes as you see them in the world around you. Lots of bathrooms have tiles, patterns, and you can have a look at those and think about them. Think about shapes in all sorts of orientations so that they get to realise a triangle is still a triangle no matter which way it's twisted and turned. And I think it's important to remember that it's not about asking the student, like, tell me what's our house number, or pointing to this and how many plates have we got, you count them. Rather, we do it, and as the learner is ready, they can join in. Or you could, when you think they're already ready, you count with me. But it's that idea that we do it and they can then copy and learn from us. Remember that number is hard but not impossible, so lots of visuals, lots of repetition strategies that are useful. So teaching kids how to count on might be put the big number in their head and then use their fingers to count on. Things like written column addition is probably not very useful. Most of us as adults don't use it at all, so it's not something that we want to emphasise a great deal, but at the time it's being learned in the regular curriculum would be an appropriate time to do it. Don't forget about teaching and practising using a calculator. Maybe I said that too much, but there you go. Maybe you can't say it too much. And don't forget that there's lots of other aspects to mathematics. I think all kids love games and they're great to use for mathematics. They do really important things. They've got activity involved with them. They're fun. They give lots of opportunity for practice, and they give lots of opportunity for modelling because you get a repeat of you have a go, then the learner has a go, you have a go, or other people have a go. And the student can watch and can learn and see how techniques are done. Hot dots is in the picture there, and if you want an idea of how that's done, just email me and I'll send you some information. It's no more important than any other game, but it's just one that I've found that kids love. I've made the point that maths is more than numbers, so geometry is one of those things. Jigsaws, water play, patterns, all those ideas are really important. I love that photo. Just makes me laugh thinking about what sort of a mother would let her daughter sit there playing with a hammer and a light bulb just there on the concrete. But I was so interested in how she'd arranged those wooden blocks into patterns with the triangles that I just had to take the photo. Measurement's practical, so it's an aspect of mathematics, but a lot of measurement that gets done in classrooms is about writing numbers down in diagrams that are on paper. A lot of workbooks that you can buy in shops to, parents to help with their kids have measurement that's like that. But measurement is practical. It's really got to be something that kids do. And here's a balance beam where you're not actually using number at all. You're comparing a potato with how many of some other objects to get a sense of what that might be. And cooking is another example where you have opportunities for measurement, but it's really where you've got to have a focus on actually doing the activity, and then it can be good fun. So we've been thinking about how to help learners with Down syndrome learn mathematics. So there are lots of things that we can do at home and in classrooms, simple little techniques. As students get older, well, there's more of a need to adjust the actual mathematics lessons that's being taught. So thinking about how that might be done is what we want to look at now. In an article that I wrote with some colleagues, Melanie Stratford and Barbara Clark, we wrote this for Australian Primary Mathematics Classroom, and if you're interested in the article, just email me and I can send a copy to you. These are the steps that we talked about, and we expand on that in the article. So rather than take the time now, you might, if you're interested in that aspect of teaching, just email me and there'll be the detail for you. And so, as we come to the end of this brief presentation, I think it's important for us just to remember that low expectations have held our learners back in so many areas, and certainly in mathematics is one of them. That idea that until they have accomplished simple arithmetic, they can't possibly do anything else, has meant that they often have not been taught anything else. We can change that. Calculation is an ongoing challenge. It's an ongoing challenge probably throughout life, but mathematics is more than calculation. With the support of a calculator, students can learn a great deal of mathematics and they can feel a real sense of accomplishment. And this is important because it matters for an individual's quality of life. So I'd like to say thank you for this opportunity to speak with you. If only I'd be able to hear what you had to say. And I hope that you might contact me on my email address, which is there. But I also would not like to finish without thanking the people who've taught me so much. Kids with Down syndrome, adults with Down syndrome, their parents and teachers. It's an ongoing journey. I hope that you'll be part of that with me as well. Thank you.